Hello everyone. In this video, we're going to go over what events are in probability. In the graphics here, A, B, and C, D, A, B, and C, we have different graphical representation of what event could be. The possible events, you can have a not E, non-event. That means in this sample space, the event occurs within this circle. And as you can see that the event or the possibility happens outside. So it's a not E. Um, Over here we have two events, A and B, and then you have this overlapping region. And so when looking for the probability of an event that has A and B, it's the overlap, what they share in common. And for OR, it's just what's between A and B. So it's all inclusive of what's in A and B. Then we have something called two mutually exclusive events. So you have event A and event B, and you see that both of them are shaded and they don't share anything in common. This is a non-mutually exclusive event because you have this overlap between A and B, and you have these common outcomes from either event. So with this knowledge, we will be able to answer these two questions. Question 4.43 says construct a Venn diagram representing the event. And so a Venn diagram is basically this picture here with the circles. And so it says draw the diagram for A and B. Well, we have that picture right here, and then you have the shaded region in between. For question B, it is A and B and C. And so I drew that here. The only thing that I did not do is the shaded region. So it is what's common in event A, B, and C that they all share in common. So that would be that. And that's how you answer that question with the Venn diagram. Moving on to 4.65. We have a table here with rooms and number of units. And you have these different events here, event A, B, C, and D. And so it says here to describe each of the following events in words and determine the number of outcomes, housing units, that constitute each event. And so I'm going to work the problems out with you. And let's begin. So question A says not A. So A is the event that the unit has at most 4 rooms. So at most, so if 4 rooms being the max, the minimum is 1. So it's the rooms that have 1, 2, 3, 4. So if it says not A, then it has to be rooms that have more than 4 rooms. So it would be 5, 6, 7, 8. And so the way we answer that, so we'll say the probability of not A. So what's the probability of getting a housing unit that doesn't have 1, 2, 3, or 4 rooms? It would be the number of all these other housing units divided by the total number of housing units, and that will give us our answer. And so 17,868 plus 19,257. So this quantity divided by the total number, which is 132,415. You can check me on that. That's basically the summation of all the housing units added together. And that will give you a number. That number will be between 0 and 1, and that will be the probability. Letter B says A and B. And so based on the Venn diagram, it's when we are looking for the probability of A and B, it's what they share in common. Okay. So let's do that. So A says it has the most 4 rooms, and then B says it has at least 2 rooms. So what do they have in common between at least 2 rooms? That means it can't have 1 room, right? And at most 4 rooms, that means it cannot be more than 4. So what it shares in common is 2, 3, and 4. Okay? 2, 3, and 4. So the probability that it is A and B will equal 1, 4, 4 plus 11 let's see 33 and then plus 23 66. Okay, divided by 132,415, which is the total number of units here. And that will give you a number between 0 and 1. That would be the probability of that. The last one is the probability of C or D. And so this is this diagram right here. So as you can see is all of A, all of B. So, but in our case, it's not A and B, it's C and D. So C says the event that a unit has between 5 and 7 rooms inclusive, so you include 5 and 7. And then that the event, the unit has more than 7 rooms. Okay? And so since it's either or, so it's either this or that, it's all that satisfies C and it's all that satisfies D. If it said and, right? If it said and, you wouldn't be able to actually answer the question if it said and, because D is asking for more than 7 and C only stops at 7. So it wouldn't be and, it has to be or. And so with that, we would do 5, 6, 7, 8. So basically it would be basically this problem again. Copy and paste. Oh, I did not paste. Let's try it again. I'm going to use the keyboard shortcut. Okay, and that will give you an answer, and that would be the probability. And as a check, remember the basics of probability, that it has to be between 0 and 1. If it's greater than 0, if it's greater than 1 or it's less than 0, then we just have to check our math and make sure that our calculation is correct. And that's how we use events in probability to solve questions like these. Thank you.